because I can technically perform oral surgery doesn't mean that it's going to be an easy thing to do. Like I mean, there's a scalpel involved, there's needles involved, and things like that, but doesn't mean that it's going to be the easiest thing to do. And it also doesn't mean that having no experience with it whatsoever, anybody's going to be too eager for me to do it, in earnest. So this is the kind of thing that maybe a quick look-see up in the front of the room is probably the best way to go. All right, so we're going to use the limit definition, and we kind of discussed this a little bit, but I don't think I ever formally stated it. I did indicate that the alternate difference quotient is the best bet when it comes to radical functions and rational functions, but I don't know that I ever actually formally stated that the f of x plus h1 is the best one to use when dealing with trig functions. All right, so when you're dealing with any kind of trig function, you're going to want to use the f of x plus h1. All right, so limit as h approaches 0 of f of x plus h, which is going to be secant x plus h minus secant of x all over h. All right, so the first part again is your f of x plus h, and the second part is your f of x. All right, now on the previous, 2 pages prior, we have rules that tell us about addition of angles for sine and cosine, but we don't have anything for secant. All right, so let's make that adjustment. Limit as h approaches 0 of 1 over cosine x plus h minus 1 over cosine of x all over h. All right, so I got a fractions that are part of another fraction. So it's telling me that I'm probably going to want to do a little common denominator action, a little keep change flip. All right, so you do that on the fly. I don't think you need to label everything up. I remember teaching algebra 2. When was the last time I taught that? Like 7 or 8 years ago now. It's crazy. But not much has changed. I mean, algebra 2, the concepts haven't changed. It's just how it's taught, I guess. I would require students in that class to show the act of multiplying top and bottom here by cosine and top and bottom here by cosine x plus h. But that's because the course had algebra in the title, right? This one doesn't. So you don't need to show that step as long as you can come up with that common denominator, and that would be cosine x, cosine x plus h cosine x, all right? So I'll just put that common denominator here. Now, if I get that common denominator, what I'd be looking at is cosine x minus cosine x plus h. All right, so I'm multiplying top and bottom of the first fraction by cosine x, top and bottom of the second fraction by cosine x plus h. Now, the one thing that would be missing here would be that h. All right, where'd that go? But that h is really thought of as h over 1. So if I did keep change flip, what I would be doing is multiplying that top fraction by 1 over h. All right, so that's what would happen to that. So just, again, on the fly, I would be taking the result of this and multiplying it by 1 over h. So that's going to place the h in the bottom of this fraction. All right. So you could show the extra steps. There's nothing wrong with that, to kind of guide your thinking and all that good stuff. But in terms of saving time and space, if the more you could do in your head, the better off I think you're going to be. All right. And there should be kind of at least an attempt to move in that direction, where you're not just writing every single detail down on paper, That's why we're learning all these intuitions so that we can just jump to conclusions. Like, you know, in life, I guess you're not supposed to do that, but here we kind of want to do that. All right, so I got that cosine x. I'm stuck with that. But now I could look at this as a rule. Cosine x plus h is a rule. 2 pages prior tells us cosine x, cosine h minus sine x, sine h. The bottom's going to stay put. We're stuck with all that. It's hideous, but we're stuck with it. I suppose you might say, well, we don't have to be stuck with it. We could expand the cosine x plus h out on the bottom, just like we did on the top. And I would say, well, don't do that. And then you would say, well, how do you know? And then I would say, well, think about what the troublemaker is here. The troublemaker is the h. I need that to cancel. I don't really care about anything else in the bottom of this fraction. Cosine x plus h, cosine x, they can stay there. They're not causing any trouble. It's the h. Because when I apply the limit, that h is going to go to 0, making this undefined or indeterminate. All right? If I can get that h to go away, then I'll know that I'm ready to apply the limit. All right? So leave the bottom alone, expand and simplify the top in the hopes that we can cancel the h on the bottom. All right. So next step, we could distribute the negative. You could also do that on the fly, but this time I'm actually going to do it out because I want to break up the fraction, and I don't want it to get too messy. So cosine x minus cosine x cosine h plus sine x sine h all over this schnitzel on the bottom. I haven't had good schnitzel in a while. Favorite restaurant in this city used to be Zum Schneider down in Alphabet City. It's like, was it Avenue B? Yeah, it's really good. Like best German food in Manhattan, I think. Oh, and their potato salad was incredible. If you're an anti-mayo person like I am, then German potato salad might be the way to go. It's the vinegar one. Vinegar bacon. Oh, yeah, it's just like, oh, it's incredible. So I'm going to break up the fraction by the plus sign in the numerator. I'm making that choice because I see that I have a common cosine x here. See, I have a common cosine x. That tells me that these two should probably be grouped together because then I could factor out that cosine of x. All right? So that's what I'm going to do. You know, just bring it in a smidge. Cosine x minus cosine x cosine h over h cosine x plus h cosine x. Just a lot of writing. But at this point, the flow of it should make some sense. You know, it's just a question of actually physically doing it without, you know, agonizing pain in your hand. Bless you. All right. So we're looking pretty good here. It may not be completely obvious where we're at, but the makings of where we're supposed to be going should be starting to come into focus. All right, because again, I have that common cosine of x here. I'm going to yank that out. And that's going to give me, well, everything else. That's going to give us that identity. Among other things, but the important part of it is the identity. And I'll chuck the other stuff in there in a second. But when I'm looking at this, I see a 1 minus cosine h over h. We know that's going to what? That's going to be 0. So this whole part of it is going to 0 out. Whole part of it. That sounds grammatically incorrect, but I'm going to live with it. All right, now the other part I think is a little bit cleaner, because if you follow the idea that, and this goes back to those limit properties in the last unit, where if they were kind of obscure to the point where they seem to violate the laws of algebra. You're like, wait, you can do that? Like if you have a limit of two things being divided, you could take the limit of the top thing and divide it by the limit of the bottom thing. And it's just like, well, how does that make sense? Well, it does for limits, right? But we also learned that if one of our rules is buried in an expression as a set of factors, we can kind of cherry pick out the parts that we need. Like in this case, we cherry picked. We had the 1 minus cosine h. I mean, we factored out the cosine x to make it more obvious to ourselves. But we had the 1 minus cosine h, and then we just pulled the h out of the bottom. Because these two divided are, with, with that limit applying to it, would give us a result of 0. So we're good there, because 0 times all this stuff is going to 0 out. Now, for the other one, we could just cherry pick the sine h over h, which is going to go to what? Oh, it's 1. That's going to be a 1. Right? So that's going to simplify right down to sine of x over cosine x plus h cosine x. I mean, you could split things out if you want. You could factor out the sine h over h. But I feel like that's, at this point, maybe not in the last unit, but in this unit, it's probably a wasted step. You know, in terms of space and time and space-time. So now I can apply the limit as h approaches 0 of 0 plus all this stuff. Well, anywhere there's an h is going to go to 0. So this is going to become sine of x over cosine squared x. All right, and so that actually ends up being a little chuckle there. I can't help myself sometimes, because you look at this mess. It's beautiful. It's just glorious. Right, but that ends up being the derivative of secant. You know how, like, the reason I chuckled is because I'm going back to, in my mind, the derivative of sine. And it was like, oh, look, it's cosine. How cool is that? And it's so simple. Sine becomes cosine. And then we found cosine is negative sine. Okay, well, not as simple, but still pretty basic. Then you're like, oh, I wonder if it's like that with secant. Maybe the derivative of that is like cosecant. It's like, well, guess what? It's totally not that. It's totally not that. So, yeah, now, just off on the rationale behind a lot of things. You know, like why do we have an ln, a natural log, instead of, you know, log base e of x? Yeah, ln is easier to write than log base e of x. All right? You don't really need new notation for that, but That's what it is. You know, somebody said, well, I want a symbol that's going to make it easier to write. All right. So we're going to say that this is equal to the secant of x times the tangent of x. All right. Now, I will tell you that there is a relationship between the derivatives of what we call cofunctions, if you remember this, also from Algebra 2. So I'm like kind of hearkening back to your favorite time in your mathematics education. Algebra 2 is his favorite course. I think when people say that they didn't like Algebra 2, it mostly had to do with like, it was this topic to that topic to that topic to that topic, and nothing ever connected them. You know, like, that's the overall theme that I usually get from people who had a bad experience with that course. It's like nothing kind of fits together. And then right at the end, it's like, let's do some statistics, you know? So that's the rationale there, but we are pulling a lot of information from there. So the concept of cofunctions, just take a trig function and slap a co on it. You have a cofunction. Or take one that has a co, remove the co, that's its cofunction. So sine and cosine, all right? Secant, cosecant, tangent, cotangent, all right? So we're about to make a startling discovery. I'll do it actually on the app. The startling discovery here. Startling. All right, so I'll be very disappointed if you're not startled at the end of this. All right, you must be startled. All right, so f of x is equal to sine of x. Yes? Why not, right? Derivative of that, we know is what? Cosine of x. But then when I take the derivative of, I'll call it g. Well, I could just keep calling it f of x. There's never a reason why you had to change it. It's still a function of x. Cosine of x. Its derivative, negative sine of x. All right. So, pattern recognition. That seems to be the theme for the week. The relationship between these two, that they're cofunctions, right? Based on the definition I just gave you of what cofunctions are. What's the relationship between these two? I don't see startled realization. You don't seem very startled.
Would it just be like, since it's sine x over cos x, just negative cos x over sine x?
So negative, I got that in there. Oh, I think I heard it. Negative cofunctions. Yeah, so it's the same relationship between sine and cosine. They're working back and forth between one another, so that co-relationship is coming into play. So we have cofunctions, but they're going to be negations of one another. All right, so if I know the derivative of one trig function, I also know the derivative of its cofunction just by finding the negative cofunction of the first function's derivative. I that's a mouthful, I know. But, so let's say I didn't know cosine at all, but I know this relationship. So I know the derivative of sine is cosine. So when I'm saying, okay, what's the derivative of sine's cofunction, which is cosine, I would just take the negative cofunction of my answer for sine. All right, so take off the co and negate it, and I'll have my derivative. So how does that apply? Well, I just figured out the derivative of secant. So that's number 6. Well, let's go down to number 9. It's written right above it. So f prime of x, in this case here, well, secant and cosecant are cofunctions, right? So what should my derivative of cosecant be?
Negative secant x.
Negative not secant tangent,
Tan
cosecant x because we're looking for negative cofunctions. So we negated it. So I negated the whole thing. I made the cofunction of secant. What's the cofunction of tangent? Cotangent. All right. So really all you have to do is figure it out one way, negate it, and add or remove cos, depending on what's already there, and you'll have the derivative of the other type of function.
Does this mean we don't have to do numbers 8 or 9, really?
You don't really have to do it, but for the experience of getting a handle on the process, I recommend you do them. All right. So, but you kind of beat me to the punch. What I'm going to ask you to do is tackle number 7 on your own or in small groups, because there's a slight little twist to that, and I want to see if you could come up with that little twist on your own first. It does still involve the sum identities, but in a slightly different way. It's a pretty interesting way. So I want to see what you got. Involving reciprocal functions, basically any other kind of function aside from sine and cosine. All right, then you'll have an opportunity to explore these on your own. So tangent functions is one we're going to go over. I did the secant function with the other class, and so after I'm done with this, I'll post it all up as a video. So if you want the direct instruction on how to do it with secant, you could watch the video. You could try it on your own, watch the video. You can do some kind of mixture of the two. All right. So for tangent, secant, sine, cosine, whatever, the best way of handling it, in my opinion, is using the ordinary difference quotient. So limit as h approaches 0 of f of x, so tangent, f of x plus h, so tangent x plus h, minus f of x, so tangent of x, all over h. So that first part is, again, your f of x plus h. And your second part is the f of x. And again, don't make the f of x plus h part overly complicated. All you're doing is taking the original function and everywhere you have an x, replacing it with an x plus h. That's it. All right. The issue here is we have tangent of x plus h. That is not one of the rules that I had typed out for you. I think it's 2 pages prior. So that's not going to work. But we do know tangent is equal to sine over cosine. So let's make that adjustment. So sine of x plus h over cosine x plus h. Tangent itself is sine over cosine. It's going to be an everyday thing, huh? Is it the wedding scene? I have no idea. Did they just turn it off? Because I was trying to figure out what it was. So limit h approaches 0. Now, we could expand this sine of x plus h, cosine x plus h, but that's going to be a nightmare. Right? You could try it if you like nightmares. I don't recommend it. We do see 2 fractions that are being subtracted. Logically, getting a common denominator should make a little bit of sense. So if I multiply, I would just bring it in a little bit. Multiply top and bottom by cosine x. And then top and bottom of this bad boy over here. by cosine x plus h. Is it like buffering or something? Like it's like a couple of words and then it stops and then a couple more words?
Who could say?
I don't know. Somebody peeking their head into next door could say, I think.
Say the word and we'll do it. Yeah, there.
The word is given. Subtle.
Talk about George Washington.
Oh, George
The
what?
bourgeoisie
Ooh.
is currently pop.
Oh,
Probably like pausing and like talking about it.
all right. So what does that word mean again?
What
It's
the
like a
French-
French-
Yeah.
I don't know.
It's a
Very-
class of
The middle class French?
Snooty.
Oh, okay, yeah.
It's like the fancy one.
Oh, fancy upper fancy middle class. Okay.
They didn't
The
each
Westchester
other up for
French.
bread.
Oh, okay. Got you. Cause there was something that I would always get it. Oh, Bolsheviks.
Yeah, it's a Russian reference.
Yeah. Well, I figured it wasn't French, but like I would always get like conceptually those things confused. So sine of x plus h, cosine of x minus cosine x plus h sine of x all over the common denominator, which is cosine x plus h. Now this whole thing is over h, but h could be thought of as h over 1. Ultimately, what I'm looking to do is take this result here and divide it by h over 1. Well, dividing two fractions is the same as multiplying by the reciprocal. Keep, change, flip. So if I multiply the result of this by 1 over h, that's just going to put the h on the bottom. I'll just tuck that in right there. Save myself a step. All right, so at this point, I would say that this is like your make or break moment, because you look at it and you can go down one of two paths. One would be to say, well, I got the sine of x plus h. I could use a rule and expand that out. I got a cosine x plus h. I could use a rule and expand that out. And I would imagine that if you did do that, you would eventually get the right answer. But based on the way I just said that, you can probably guess that that's not the way I would encourage you to do it. All right? So just going back to the sine rule, the sine difference rule, it's sine of a minus b is equal to sine a cosine b minus cosine a sine b. All right, this numerator seems to be the expanded form of that rule. All right, so this whole shebang here seems to be equivalent to this. So really what we want to do is take this and work our way back to that. Simplify instead of expand. All right? Because if we do that, well, simplifying is a good thing. It should clean up in such a way that that h is going to cancel. All right? The h is the troublemaker in the bottom of the fraction. If I were to apply the limit, h approaches 0, that makes it undefined. If I can get that h to go away, we'll be in good shape. All right? So if a is equal to x plus h and b is equal to x, that makes this expression that I highlighted here equivalent to the one that I have written as part of the limit. All right? So that means that I can do a substitution of the limit as h approaches 0, the numerator would now become sine of x plus h minus x all over that stuff on the bottom. Yeah. So I got an x. What's it mean? What's bourgeoisie? 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 What is the word? Bourgeoisie. I put an R. I put an extra R in there.
Because it's there, it's just silent.
Oh,
So I'm not gonna hold it against you.
I appreciate that. I needed a break. All right, so the x and the negative x are going to cancel out.
Like out of room.
Me too. All right, so what we have now, embedded in this beautiful mess here, is a sine h over h. Limit as h approaches 0 of sine h over h is equivalent to what? 1. So now I have 1 over cosine x plus h. So what's my equivalent expression here once I apply the limit? One over cosine x, cosine x, right? So cosine squared x, which I could represent as, what's 1 over cosine equivalent to? Not that. Secant.